how internet works and what librarians can do to handle different kind of web resources. The structure of this particular tutorial is actually based on 4 different platforms. First one is the Open and Distributed Information System, what we colloquially called internet. Then whole internet is basically built on the top of open source software and open standards. Like when you are accessing internet, you are using lot of open source software. Like for example, 95% of the web servers are using Apache as web server software. They are using MySQL, PostgreSQL as database management system. Most of you people are using Mozilla Firefox, Opera. These are the web browser you are using. These are all open source software and many open standards. Say for example, the whole internet is based on a standard called TCP/IP, and TCP/IP is an open standard. HTTP, FTP, Telnet, all are open standards what we are actually use to connect remote clients to the remote servers. Now on the top of these 2 building architecture, that is the internet as a platform and open source software and open standards as tools, we are slowly getting to beautiful products which libraries can be utilized intelligently, collectively and interactively. And these 2 products are basically called Open Access Publishing System, or we simply sometimes call it as Open Access, and Open Learning Resources. These 4 fundamental facets of internet, that is the internet as a platform, it's basically acting as a platform for scholarly communication. Then as I told you, open source software and open standard acting as ingredients for building services and utilities. And on the top of these 2, Open Access Publishing System, this is basically generating lot of open knowledge objects, and Open Learning System, disseminating of learning resources across the globe. Some of you must be accessed different kind of video tutorial, learning video tutorials available in YouTube and different other sources. Some of you may be using that SlideShare project. A lot of slides on different topics you can download, you can view, you can learn many things. So these are all happening actually on the basis of internet as a platform. But before making a quantum jump into the core of the internet, here I would like to quote the famous lexicographer Dr. Samuel Johnson. He once said that knowledge is of 2 kinds. We know a subject ourselves, or we know where we can find information on it. It simply means that knowledge has 2 facets. That is, the first facet is what is the knowledge, and second facet is where is the knowledge. So as we are basically library professionals, you are the would-be library professionals, so it is very essential to know that where is the knowledge, so that you can help your user in finding right information at the right time and in a right manner. So this particular video tutorial will help you to harness the collective intelligence produced by the World Wide Web. Now before, again, as I said, that internet is basically creating a lot of opportunities. Open knowledge movement is one of them. Before attacking that particular concept, we need to know what is open knowledge movement, what are open knowledge objects, etc. Now by definition, open knowledge is a term used to denote a set of principles and methodologies related to the production and distribution of knowledge objects in an open manner. Now it can be data, it can be contents, it can be general information, it can be journal paper, thesis, etc. And everything is open. Now what is everything? That means the whole process is actually supports the open submission, open peer review for quality control, and open access by anyone at any time without any discrimination. You can define as knowledge is open, or a particular knowledge object is open if it is free to use, reuse, redistribute without legal, social and technological barriers or restrictions. And internet is basically helping us to move in that particular direction, and it is acting as a platform through which we can share, we can distribute, we can redistribute, we can access different knowledge objects, and in most of the cases these are available free of cost if you know the proper source or proper web address to access it. We are starting our the first component of our discussion, that is internet, and you will be amazed to know that internet started its movement long back in 1969, but within 50-60 odd years it became very popular throughout the world. It's basically a distributed information system. It's based on open standards like TCP/IP, HTTP, packet switching technique, Unicode to access multilingual resources. It is based on open access principles. That means everything is accessible to everyone, and it supports electronic democracy. That means anyone is welcome to access internet, and most of the web services are built on the top of open source software. So these are some of the characteristic features of internet as a platform for scholarly communication. Now one question definitely it's coming to your mind, that how internet works. Although you have covered your different modules related to internet, but here you can see that how internet works. Now if you look at the picture, here you see the global map is basically there. It represents the entire earth, and internet in the middle is working as an information superhighway, and almost all the countries are connected to the information superhighway through a concept called gateway. That means internet is the backbone of scholarly communication at the global scale. This is called internet or internet as information superhighway. Now, as I told you that anyone can be connected to the internet. So suppose at the individual level, how can you connect to the internet? For example, in your home you have a computer. If you look at the picture, that computer is connected to a telephone line via a communication device called modem. Modem is basically supporting conversion of analog signal into digital one, and vice versa. That is, it takes analog to create or to convert it into digital signal. Again, it takes digital to convert it into analog signal. So your home computer is connected to the telephone set through modem. Then this telephone set is basically connected through your local exchange to the that is called a particular telephone network, that is called PSTN, public switch telephone network. Through public switch telephone network, as you can observe from the picture, that this connection goes up to the gateway. So gateway means the internet service provider for the country. So gateway is basically connected to the information superhighway in this way, and different kind of packets are coming and going through this particular gateway. Now, as you know that how a particular PC can be connected to the internet. Now you see, in a particular organization, it's quite impossible to provide individual connection to each PC. For a campus like say Netaji Subhash University, Open University. Now in that case we are basically using a LAN architecture. That means all of the machine in a particular campus will be connected to the LAN, and LAN will be connected to the the gateway, and the gateway will be connected with the information superhighway. If you see in the picture, here you see the directly in the gateway is basically opening into the local area network, and each of the machines in a particular campus will be connected to the LAN, and each of the machine will thus be connected to the internet. So this is the concept of gateway and how it can be connected to the institutional level LAN. Now here you see that suppose you are sending a particular mail. The mail will be divided into number of packets. Each packet will have an IP address, that is the IP address of the receiving server or receiving computer, and your packet will carry the IP address of your machine. Now the packet will be moving, as you can see from the picture, will be moving to the gateway internet access system of India. Suppose if in case of India, then this gateway internet access system is connected to the information superhighway. There is a machine called router the job of router is to open up each and every packet and send it to the destination on the basis of the IP address given there, and at the receiving end the packets will be assembled to form your email. So first you are sending a mail that will be divided into number of packets. Packets will be actually carried forward to the destination by the router, and at the destination end all the packets will be reassembled to create the email, and your friend can see your email. So in this way internet works on the basis of packet switching technology. Now definitely the next question is coming to your mind, that why internet is so popular. Within 50 odd years since the inception of internet, it became very popular across the world because there are 6 reasons. Internet is basically powered by any to the power 6. That means if internet is a platform, as you can see from the slide, that any user from anywhere at any time can access internet for accessing any information in any language and in any format. So this power of any to the power 6 is making internet very popular across the globe, across the generation, and across the community. Now, as I told you, that internet started in the year 1969 with the service or feature called Telnet. What is Telnet? Through Telnet, a remote client can connect a remote server to utilize the hardware-based software, data, program available in the server. But Telnet failed to exchange file from the client to server. So next important service and protocol came. This is called FTP, File Transfer Protocol, through which we can transfer a file from the client to the server and vice versa. That means we can have or we can transfer file from server to client also. Then came the Archie as an indexing service for FTP servers. Then Gopher came as a menu driven system. And finally during 1992 to 1993, Tim Berners-Lee developed lightweight HTML programming called HTML, Hypertext Markup Language, and that basically changed the way we access internet, the way we use internet. So this is basically called the World Wide Web. It is based on the graphical user interface. Remember, in case of Telnet, FTP, Archie, you need to know a set of Unix commands because the whole internet is based on the Unix clone, that is the Unix-like operating system. So you need to know different kind of commands if you are trying to use Telnet, FTP, Archie, etc. But in case of World Wide Web, you don't have to remember any command because the entire thing is based on the graphical user interface. It supports multimedia. Previously internet was textual, now it supports text, data, audio, video, streaming video, everything. A true multimedia environment. And most importantly, it facilitates hyperlinking. That means by clicking a particular link given there, you can reach to any computer to access any information. So because of this epoch-making features as provided by the World Wide Web and as developed by Tim Berners-Lee, internet became very popular in the public domain. Because previously internet was mainly used by the scientists, engineers, academia, researchers. Now after 1995, internet came into the public domain. So users at general can utilize different services offered through internet. Now as a librarian or as a library professionals, we are mostly interested in the different kind of scholarly objects available in the internet, and these are called web resources. Most of the cases these are available in HTML format or in XML format or PDF format or some proprietary format like doc, PPT, etc. So these are basically called web resources, and users at their end normally retrieve these resources by searching different kind of search engines. But their approach creates a lot of problem in retrieval, because web, you see, it's basically a textual platform. So the moment you are searching by a query without giving any kind of special operator or something like that, it retrieves a huge number of records for the searcher, and it become very difficult for the searcher to know which one is the most relevant for his or her query. Now, as a librarian, you need to tackle this problem. You need to guide your users in internet searching. For example, tell your user that there are mainly 3 kind of web searching tools available in the web. The first one is called the subject directory, that can again be divided into 2 groups: academic subject directory or commercial subject directory. Then search engines are there. These are text-based search engines or visual search engine. And finally meta search engine. And the search sequence should be like this, that most of the cases people directly jump into the search engine, but that is not the right approach. You need to tell them, and you need to follow also for your personal searching, that first you need to know what are the subject directories available, because they will give you a small set of resources but highly relevant as per your query. Then after accessing those materials, those limited resources, you come to the search engine, and you need to know how to search properly, because searching by typing a few keywords will not give you any kind of satisfactory result. Then if your search engine could not provide you required documents, then you please come to the meta search engine. So this should be the sequence. Now, what is a subject directory? Subject directory is basically categorization of web resources on the basis of certain standards, and a group of human indexers are basically judging the quality, judging the resource categories, and finally they are indexing it. So in subject directories you are getting a small set of relevant documents where relevancy is ensured, because a subject expert is judging the quality and categories of those particular resources. Then comes the search engine. Now, what is a search engine? Search engine is basically based on a system called automatic crawler. They send robot or crawler to different kind of sites. The crawler directly sends the cache image of those resources into the search engine database. Now, search engine indexes those actually resources at their server end. So as a result, what is happening, that most of the resources do not get any kind of metadata, like who is the author, what is the title, what is the subject. So search engines tends to index each and every word, excluding some of the junk words like preposition, conjunction, etc. So as a result, what is happening, as search engines are based on the word level indexing, anytime you are searching anything, search engine produces a lot of retrieval sets. So that means, suppose you are searching by any query, it will say there are 2 crores of documents available. And then comes the meta search engine. Meta search engine is basically a search engine of search engines. Now, if you see the slide, here you can see basic differences between these 3 web searching tools. So subject directories are basically based on the human indexer. Here relevancy is ensured, and it is actually follow a certain kind of categorization of the knowledge. They have their own databases, and typical range of resources included in a typical subject directory is basically in the tune of millions of pages, and it's very useful when you need a set of highly relevant document. On the other hand, search engines are based on the automatic crawling. They do not apply human indexing system. Here relevancy is to some extent ensured depending on the different kind of algorithm used by the search engine. Most of the cases they follow not categorization of the knowledge, they follow their own page ranking algorithm. Say for example the famous Google page ranking algorithm, what is basically a patented piece of software. Then the typical range of search engine includes in the tune of billions of pages. That is a huge number of web resources they basically covered. In fact, the largest search engine of the internet is not Google, it's Northern Light. It covers 33% of the whole web, and Google covers only 16% of the whole web. And when it is useful, it's very useful when you need to explore what is available in the public domain comprehensively. Now on the other hand, and they have their own databases. On the other hand, if you compare meta search engine with the search engine, that meta search engines are basically based on the federated search program. Actually, they take query from you and forward your query to number of search engines. They have their agreement with different kind of search engines. Here, relevancy is not at all ensured because meta search engine typically based on the search engines different kind of algorithm. They don't have their own databases. They don't have their own search mechanisms. Say they are basically using databases of search engines, and typical range, as you can imagine, it's billions and billions of pages. The only advantage is that you don't have to use different kind of search engines at one go. Instead of that, you come to a meta search engine, type your query, it will forward your query to a number of search engines and will check, duplicate and give data or the result back to you. So that is the advantage of meta search engine. You can avoid roaming from search engine to search engine databases. You can use it's basically acting as a one-stop access. Now, University of Berkeley Central Library developed a very good tutorial, and you can see this is basically the tutorial available from the web. You go to that particular address given in the slide, and you can have different kind of good tutorials to know how search engine works, what are the subject directories, how meta search engine works, etc. Now, you will be amazed to know that librarians are basically doing miracle in organizing web resources.